today I'm going to be introducing the concept of exponent properties, okay? And guys, remember your exponent is the little number in the top there, and it just means that you multiply it by a power of something. So guys, the very first rule that I want to cover with you guys is this 0 as an exponent, okay? So first of all, I want you guys to take out your calculator, and I want you guys to type in 5 to the 0 and tell me what you get. All right? So if you do 5 to the 0, let us see what you guys get. What did y'all get when you do 5 to the 0, y'all? 1. Awesome. Okay. Now I want you to pick any number you want. Let's preferably a positive number. All right, let's do a positive number first. Any number you want, and do it to the 0th power. I'm going to do 64. 64 is my favorite number. So 64 to the 0 power is also equal to 1. Interesting, y'all. So, guys, here we are. The 0 as an exponent is any non-zero number raised to the 0 power is 1. All right, guys? Ooh, I got a little bit long there. So, guys, any non-zero number raised to the 0 power is 1. So, guys, x to the 0 would also be considered 1. All right, guys? So, 5 to the 0 is 1. X to the 0 is 1. Now, guys, negative 2 to the 0 power. Guys, is the negative being raised to the 0 power, or is just the 2 being raised to the 0 power? So let's check this out. I'm going to show you a different one here. If we have negative 2 to the 0 power, that's going to be different. So, guys, this negative on the outside here is the same thing as negative 1 times 2 to the 0, which is really negative 1 times 1. So what would that give me up here on the top? That would be negative 1. But guys, if your negative number is inside of a parentheses, that entire thing, negative 2 to the 0 power, that would be raised to, that right there would be positive 1. All right, guys? And you can see that that's backed up here. If we do negative 2 to the 0 power, we get negative 1. But negative 2 to the 0th power is a positive 1. All right? So if you raise negative 2 to the 0 or negative 2 to the 0 power. All right, guys? So those are a little bit different. But basically, if you have a number and it's raised to the 0 power, it is equal to 1. Do y'all feel good about that? Awesome. It's kind of a lovely little simple rule. Now, guys, we're going to be jumping into a series of rules that are also found on your formula chart. So, guys, we are covering these properties of exponents. Guys, notice this rational exponent, this one, we did last class, right before Thanksgiving break, right? So we did this in the last class where we raised that and we just rewrote it. If it was a fractional exponent, we could rewrite it as a radical. Next up, we're going to be talking about this negative exponent rule. And then, guys, we're actually going to be covering the rest of these rules today as well. So this little section of your formula chart, we will have covered everything on it before we are done here today in that little properties of exponents. So, guys, your negative exponent rule. So if you're a highlighter person, go ahead, you can highlight this rule. All right, guys? And so what this shows us is that if you have a negative exponent, we can't really, we don't want to have negative exponents in our answer. So we want to change our negative exponents to be positive exponents. So you can write it like this. This n, a to the negative n can be flipped down and make it as 1 to the positive a over n. Or, guys, another way that you can see it is if we have 1 over a to the negative n, that becomes a to the positive n. So guys, what we want is we want no negative exponents in the answer. And so guys, our basic rule here, how we kind of describe this, is guys, you move the bases with the negative exponents. Oops. To the other side of the fraction, all right? The other side of the fraction bar, and you make the exponent positive. Okay? So what we are doing is we are shifting whatever has the negative exponent, we move that base to the other side of the fraction bar, and then you make the exponent positive. Okay, but Miss Humanek, what if we don't have a fraction bar? Well, if there's no fraction bar, then you just make one by putting it over 1. All right, guys? So this negative 3 to the, or this 3 to the negative second power, guys, what we can do is we can take this little guy, and because that's a negative exponent, we are going to move it down to the bottom side of the fraction bar. And what happens is that becomes 3 to the positive 2 now. But nothing got left behind, so we need to have a little 1 as a placeholder. And guys, what is 3 squared? Yeah, we have 3 squared is going to give us 9. So this is really the exact same thing as 1/9. Are you guys comfortable with that? All right, I like number 5 and 6 because they're similar, but there's a big difference there with that parentheses. Okay, so there's a big difference there with that little parentheses. So let's take a look at number 5 here. This negative 4 is raising all of that negative 3 to the negative 4th power. So guys, we are going to take this entire thing and move it now to the bottom of the fraction bar, all right, down into the denominator. So that becomes negative 3, but now instead of negative 4, it becomes a positive 4. It left nothing behind, so I'm going to put a little 1 there as a placeholder. And then, guys, we go here and we say that negative 3 to the 4th power is 81. So that becomes 1 over 81. Are you guys comfortable with this so far? If it's in the top of the fraction, you move it to the bottom of the fraction. Okay, but you only move what has the negative exponent. So guys, for this one right here, there is no fraction bar, so I'm going to make 1 there, do it over 1. And guys, this negative to the 4 power is only being applied to the 3. It's not being applied to that negative. So we're only going to move the 3 down to the bottom because the parentheses, there is no parentheses, so that negative is not included. So we leave behind the negative, and we have to have a little placeholder of a 1. And that gives us negative 1 over, and we already know, well, 3 to the 4th power is 81. So that becomes negative 1 over 81. This is not, I don't have this. Sorry. All right, so we have negative 1 over 81. You guys feel good about that? All right, let's take a look at this one right here. So for number 7, now we have something on the bottom of our fraction here. So y'all, does my 1 have a negative exponent? Nope, so we don't have to worry about that. We only have to move things that have negative exponents. So this x to the negative 3 is going to flip to the top. So that becomes x to the positive 3. Now nothing got left behind on the bottom in the denominator, so do I need to put over 1? No. Now, it's not wrong if you do that, but to be fully simplified, you really don't need to put that it's over 1. You can keep it there if you want to have a little place value, but guys, it really, once you take it out of the bottom, you don't have to leave. If there's nothing there, you can just do it over 1. Okay? Now, the same is true for number 8. You have a negative exponent. It's going to move up to the top. So that becomes 2a to the positive 4th. And nothing got left behind. So we're going to do a little 1 as a placeholder. But that's really just 2a to the 4th. All right, guys? And then for number 9, this one is interesting. I like this one. Because, guys, let's take care of our negative exponent first. 6 is not negative. 3 doesn't have a negative exponent. But this little t to the negative 6 is a problem. Do y'all see that? So we're going to move it up to the top. So that becomes 6t to the positive 6 over 3. Because 3 got left behind. Do y'all see that? But can we simplify 6 divided by 3, y'all? We absolutely can, guys. What is 6 divided by 3? 2. So that leaves us with 2t to the 6th. So that would be my final answer. And we don't have to, I guess you could do 2t to the 6th over 1. You don't need to do that right there. All right, guys? Are y'all comfortable with our the negative exponents? Basically, you just flip floors. All right? If it was in the numerator, it comes down to the denominator. If it was in the denominator, it pops up to the numerator. Do y'all feel good about that? Okay, so it just flips floors. All right. Next up, guys, we're going to talk about our product rule. All right, guys, so this is this is actually the very first thing, this product of powers. This is the very first rule that's on your formula chart. Okay? So if you guys want to highlight this, then you can. All right, guys, because this is super important for us to understand. So, guys, this is the basic rule. When you are multiplying expressions with the same base, all right? So when you are multiplying with the same base, there are two big things that you will do. All right? You keep your base. All right? So when you're multiplying with the same base, you keep the base. And then, guys, what we do is we add our exponents. All right? I'll go here. We add, I'm actually going to do it with a different color. Sorry. Please forgive me. Same words, just different color. All right? So we are going to add the exponents, and then you are going to multiply your coefficients as normal. All right? So you add your exponents, but you multiply your coefficients like you normally would. All right? So in this particular case, for my very first one here, x cubed times x to the 4th. Well, guys, these have the same base. Do you see how x and x, those are my same base? So what we are going to do is we are going to add the 3 and the 4. So, guys, that becomes x to the 3 plus 4. So that would become x to the 7th power. So, guys, this is a little confusing because you're multiplying the two things together, but you're adding your exponents, okay? So that's just one of those rules. When you multiply the two powers, you add the exponents, all right? But then, guys, you still multiply your coefficients as normal. So let's take a look at this guy right here. So the first thing we're doing is we do 3 times negative 4. Well, guys, what's 3 times negative 4? 3 times negative 4 is negative 12. And then, guys, because a to the 4th and a to the 6th, guys, we are going to add that 4 plus 6. So this becomes negative 12th a to the 10th. Are you guys okay with that? And so guys, this right here shows us that m plus n, when you have m and n and you're multiplying your bases together, you add your exponents. All right, guys? When you multiply things that have two powers, you are adding your exponents. So let's take a look at number 12 right here. So the first thing we're going to do is we are going to multiply our bases. So 2 times 3 gives me 6. All right? And then a cubed times a squared should give me a to the, what should it be? 5th, because we are adding exponents. All right, guys? I can tell you right now, if this was a multiple choice problem, some wrong answers, all right, that people would give me would be 6a to the 6th. Why would 6a to the 6th be a good wrong answer for that one? They multiplied the coefficients and they multiplied the exponents, okay? Another good wrong answer would be 5a to the 5th. Why is that a good wrong answer? They added the coefficients. All right, guys? So you have to kind of like work your brain a little bit. You have to remember the rule. When you're multiplying two things with powers, all right, you have to remember you multiply your coefficients and you add your exponents. So those, I guarantee you, if this was a multiple choice problem, both of those would show up as potential wrong answers. Does that make sense? Because you kind of see why. All right, let's take a look at this guy right here. All right, can we, here we go. All right, guys. Hey. Hi. Welcome. Good to see y'all. Welcome back. All right, here we go. So, we were making some noises, so that's why we needed to wake up there. All right, so, guys, here we go. We're going to multiply these guys together. So, negative 5 times negative 8 gives me a positive, negative times a negative, guys. So that's negative 5 times negative 8 gives me a positive 40. All right. And then we have x cubed and x fourth. What do we do to those exponents right there, guys? Add them together. So that becomes x to the 7th. And then, y'all, now we have another base. I've introduced in another one. So y7 and y squared, what's that going to be, y'all? Y to the 9th. So, guys, you have to make sure you keep your x's with your x's and your y's with your y's. You've got to keep them together, okay? So you only add exponents from the same base. You only add exponents of the same base. So they have to have the same base for you to be able to add your exponents together. Does that make sense, y'all? So we only added x's with x's and y's with y's. So let's take a look at number 13 here. All right, y'all? If we do 13, negative 4 times 11 gives us negative 44. Okay? And then x7 and x fifth would give us x to the 12th. Is that right? 7 plus 5 gives us 12. Do we feel good about that? All right. And then last but certainly not least, we have y6. And then, guys, we just have a y by itself. Ooh, what's that? When there's no exponent, what's the invisible exponent there? A 1. So that becomes y7th. You're exactly right. Good job, Joey. So, guys, for that particular one, I want you to remember if there is no exponents, it is a 1. All right, guys? So if there's no exponent, there is a little 1 right there. All right? And then last but certainly not least, let's look at this guy right here. We're going to do 1/2 times 4. Well, guys, 1/2 times 4 gives me 2. Awesome. And then we have x cubed and x1. So that would be x4. And then, guys, there's only a y2 in this section. So do we have anything to add it to from the first factor here, right here? We do not. So it's just y2. So you just add the x's with the x exponents and the y exponents together, and we get them all together right there. You guys feel pretty good about that?
Yeah.
Awesome. So, guys, this is our product rule. When you're multiplying things with the same base, you keep the base, you add your exponents, and you multiply the coefficients. All right? So that is our lovely little rule right here. We are. We're doing one more page, and then we are done today. So, guys, we got 12 more problems, and then we're done. All right? Now let's take a look at this guy. This is our quotient rule. All right, guys? Quotient rule is division. All right, guys? So now we are dividing exponents. All right? Or dividing things that have powers or have an exponents. So, guys, this is our rule right here. When you are dividing exponents or dividing powers with the same base, what does the rule look like it tells us to do?
Minus exponents.
Now we subtract exponents. All right, guys, so you keep that base, but you subtract your exponents, and then, guys, you do exactly like you would with the multiplying, but now we just divide our coefficients normally. All right, guys? So before we multiplied our coefficients normally. Oh, man, you can't see it. Once again, sorry. But now we divide our coefficients normally. All right, guys? So we are going to follow this rule, these lovely little rules here. So, guys, for 16, let's take a look. So the first rule is with our coefficients, we are going to divide them normally. All right? So 8 divided by 2, guys, what's that going to give us? 4. And then, y'all, we have x to the 4th and x squared. So we are going to say x4 minus 2. So, guys, what is x to the 4 minus 2? That gives us x squared. So that right there is 4x squared. So all we did was just subtract our exponents, and we have that 4x squared. Do y'all feel pretty good about that? Mm-hmm. Awesome. All right, now let's take a look at this guy right here. All right, so when we have one like this, we are going to divide our coefficients normally. So 8 divided by 10, how can we simplify those, guys? That's what? 8 divided by 10, y'all? I think it's 4/5, right? Because you can divide them both by 2. So 8 divided by 10 reduces to 4/5. All right? And then, guys, we are going to look at this. We have our x. We have 2x, 2 minus 5. And then we have y, 6 minus 2. Do y'all feel good about that? So, guys, that becomes 4/5. But then, guys, we have x to the negative 3, don't we? And y to the positive 4. Well, guys, can we have a negative exponent? What was that rule? It was on the very first page there, guys. We don't want any negative exponents in our answer. So what do I need to do to get rid of this negative exponent? Move it to the bottom. Right? So, guys, I have my, my x is going to actually pop down here and become x cubed. And my y is going to be y to the 4th. Do y'all see that? But what happens now? We still have our 4/5, so we're going to have that separated out like a lovely little fraction. Okay? So that becomes 4 over 5x cubed. Are you guys okay with that? Now, another way that I like to think of this, guys, on 17 is technically you're still subtracting your exponents, right? The 5 and the 2 right there. But do you see how the 5 has the bigger, that x to the 5th, that's our bigger exponent, right? So where did my x end up? On the bottom. Do you see how y6 and y squared, do you see how 6 is the bigger exponent for my y's? And where did my y's end up? On top. So guys, wherever the bigger exponent is, that's where your base is going to end up. Does that make sense? Because that's x to the 5th over, and then x squared is on top. The x 5th was bigger. So guys, our x cubed ended up on the bottom. So you can still subtract your exponent, but you can think about it. I like the one that has a bigger exponent has more weight or more gravity, so it kind of pulls it to wherever it is. Okay? So you can also think of it like that. All right? So looking at number 18, let's look at this one. We're going to do this one by doing the subtraction, and then we're going to go there. Yes, sir. Yes. All right, guys. So let's simplify these exponents right here, okay? So negative 14 over negative 7, guys. How does that reduce? That's going to be a positive 2 because a negative over a negative. And then, guys, we have x5 and x4th. So, guys, that's going to be 5 minus 4. And then, guys, we have y4th and y to the 4th. So that's going to be 4 minus 4. Well, guys, that gives us 2x to the 1, y to the 0. So, y'all, do we really need, what is anything to the 0th power? That's just 1, isn't it? So, guys, that's going to just become a 1, which is great. And do I really need to write x to the 1? Nah, so it's just going to be 2x. All right, guys, so our final answer would just be 2x. So, guys, when you see two numbers that are the exact same on top of each other, y4 and y4, you can just cancel them out because they're just going to go away, right? When a number, it turns into 1. So you can just cancel them out like so. All right? Does that feel okay? You guys understand that? Yes, no, maybe so? All right, so I'm going to do this. I'm going to do number 19, or actually, let's do number 20. And then we'll jump over to 19 and 21. All right, guys? So what I like to do is I like to think about it like this. So I like to write out my new little fraction. So, guys, negative 5 over negative 10. What's that going to be, y'all? Negative 5 divided by negative 10. Well, negative by negative is going to turn it into a positive. And it's going to be 1 over 2, right? Because we're still simplifying, right? Negative 5 over negative 10 is just 1/2, right? Negative 5 divided by negative 10 just gives us a positive, 1/2. So you can see that guy right there. So that's 1/2. And then, guys, let's go ahead and do our x cubed and x1. So, guys, what are we doing to those exponents? Are we adding, subtracting? What are we doing? So what's 3 minus 1, y'all? 2. And which one has the bigger exponent? The top. So it's going to end up on top. So it's x squared. And then, guys, we have y squared and y6. And, guys, where's my bigger exponent? Is it on top or on bottom? So it's going to end up on the bottom. So, guys, and what is 6 minus 2? 4. So that right there will give us, now do I really need 1x squared or can I just write x squared? Let's just write x squared. X squared over 2y to the 4th. All right? X squared over 2y to the 4th. All right, y'all? Now we're going to go over here. We're going to do numbers 19 and 21. Sorry. Shift it over. All right, guys. Are you guys okay if I don't write out every step? Are you guys okay if we talk through the 3 minus 1 and the 6 minus 2 like that? Okay. Because when you do it on your paper, you're not going to write out like the minus steps. You're going to probably do that in your head. So let's take a look at this part right here. So 12 divided by 9, how can that simplify, or how can that reduce? 12 divided by 9, yep, will give us that 4/3. They're both divisible by 3. So that 12 divided by 9 gives us that lovely 4/3. And then, guys, we have x to the 6th over x to the 9th. Ooh, so guys, which one's bigger? The bottom. So it's going to end up on the bottom. And what's 9 minus 6? 3. Now, I'm going to be honest, guys, this kind of drives me crazy when it's like off center like that. So that is perfectly acceptable, but I typically rewrite it so that like my 4 is in the center. I know that's silly. But y'all, I just like it to look a little bit cleaner. That just looks nicer to me. It literally is the exact same thing, but that one's just centered. All right, you don't have to do it, but this is perfectly acceptable. Okay, guys, so we have 4 over 3 x2, and then 4 over 3 x cubed. All right, guys? Now let's take a look at this last one, number 21 here. All right, guys, we have 3 over negative 18. So they're both divisible by 3, right? So that's going to be negative, so that's 1 over negative 6. Are you guys okay with that? Y'all good with that? Yes, ma'am. All right. And then x cubed over x cubed. What's going to happen when we have x cubed over x cubed, y'all? The same number over itself. What happens to it? Cancels out. That goes away. We don't have to worry about that. Okay? But then we have y1 over y cubed. So guys, here we go. Which one's bigger, y1 or y cubed? So it's going to end up on the bottom, and 3 minus 1 is squared. So guys, I personally will rewrite it just so that it looks a little more centered. And so I'm going to put my negative out in the front. Negative 1 over 6. Oops, that should have been pink. Sorry. 6y squared. All right, y'all. So we have our negative 1 over our 6y squared. Guys, are those the exact same thing? Yes, they are. That one just looks a little bit prettier because it's centered. All right, you can do it either way. Does that make sense? Y'all good? Okay, do y'all have any questions about the quotient rule? No. So when you multiply powers, you're adding your exponents. When you're dividing powers, you're subtracting your exponents. The biggest thing to be aware of is, guys, sometimes if your base is bigger on bottom, then your base ends up on the bottom. If your base is bigger on the top, then your base is going to end up on the top. Does that make sense, guys? So it depends on which base has the larger exponent. All right? Now, this is our very last rule today, okay, guys? We're going to talk about this power-to-power rule. All right, guys? So my power-to-power rule is a little bit different. Now we are taking our exponent and we are raising it to another power. So, guys, this is important. When a power, or when an exponent, when a power is raised to a power, what we do is we are going to multiply our exponents, and then you are going to raise the coefficient to the power. So you are going to raise, oh no, I'm going to run out of room. Dang it. You're going to raise your coefficient, oops, to the power. All right, guys? So when we have these guys right here, when a power is raised up to another power, you multiply your exponents and you raise the power to the power. So you keep that base, but you multiply your exponents. So let's take a look at this one right here. This one would be nice and simple. All right? So we have our x squared, and we are raising it to the third power. So what we are going to do is we are going to do x to the 2 times 3. And guys, for this one, this becomes x to the 6th. And guys, I guarantee you a wrong answer would be x to the 5th. All right? They would be counting on you to apply the wrong rule. All right, guys? So you want to make sure that you apply the correct rule here. All right, we're going to go down. We're going to do all these even ones first, okay? We're going to multiply our exponents and raise the coefficient to the power. So, guys, this is where a lot of people get confused. So this right here will actually become 2 squared, all right? And then we take our x, and remember that's like a 1, and it's x to the 1 times 2, okay? Because what we're doing is we're going to multiply that. I think about it because it's got parentheses, y'all. It's like distribution, so we're multiplying. Does that make sense? So we're multiplying that power in there. So 2 squared is going to give us what, y'all? 4. So 2 squared gives us 4. And then x to the 1 times 2 gives us x squared. So that becomes 4x squared. All right, y'all? Now let's take a look at 26 because this one is interesting. Okay? So guys, we raise the coefficient to the power. So that becomes 5 cubed. All right, y'all? And then we have x to the 4 times 3. And then we have y to the 1 times 3, because that's our little invisible exponent of 1. So guys, what is 5 cubed here? Let me give you a hint. It is not 15. That is the most common wrong answer. We are not doing 5. Yeah, we're not doing 5 times 3. We're doing 5 3 times. So it is 125. So that right there gives us 125, x to the 12th, y cubed. So guys, in this case, we are multiplying our exponents, and we are raising the coefficient to the power. All right, guys? Now for these, my coefficients were all positive. So we just raise that coefficient to the power. All right? Hey, Riley, we got 3 left. Do you mind hanging on? And then you can head right after we're done with these 3. So guys, when you have a negative coefficient, when you raise a negative coefficient to that power, I want to give you guys a little hint. Please keep it in parentheses. All right, guys? Because if you don't, then it gets just really grumpy with us. So it's negative 3 squared. And then, guys, we have x to the 1 times 2. So that really becomes negative 3 squared in the parentheses here would give us a positive 9. Because negative 3 times negative 3 gives you a positive 9. And then x, 1 times 2, is just squared. So guys, I'm going to be honest with y'all. I typically don't write out this little step with my exponents. I do that part in my brain. So for 25 and 27, I'm going to do that part in my brain and talk you through it. Okay? But I still write out my coefficient. So I say that's negative 2 raised to the 2nd power. All right, guys? And then I say that is x. And guys, I'm going to do 2 times 2. So that would give me x to the 4th. And then y to the 3 times 2. So that would be y to the 6th. All right, guys? So we are multiplying those exponents. All right, guys? So now my negative 2 to the 2nd power would give me a, you can't really see what I'm typing. Negative 2 to the 2nd power gives me a positive 4, because negative 2 times negative 2. So that would be 4, x to the 4th, y to the 6th. All right, guys? And then let's look at this last one here. Ooh, being raised to the 1/2 power. Interesting. All right, being raised to a fractional power. So guys, we are going to take 9 and we are going to raise it to the 1/2. And then, y'all, so we took our 9 and we're going to raise it to that 1/2 power. And then, guys, we're going to take our x. And, guys, what is 4 times 1/2, y'all? 2, yes. 4 times that 1/2 gives us 2. So, guys, it even works with fractional exponents. And then we do y squared. So that's 2 times my 1/2. And so what's that going to give us, y'all? 1. So that becomes y to the 1. Well, guys, now let's go ahead and do 9 to the 1/2 power. All right, 9 raised up to the 1/2 is going to give us a 3. So that's 3x squared y. Because we don't really need to write the y to the 1. If you have a y to the 1, if you have anything raised to the 1, you can drop that exponent right there. All right, guys? So hopefully that gives you a good grasp of what's going on. So, guys, for our exponent rules, we went over these 3 today. There's a few exponent rules here. Guys, your negative exponents, they switch floors, right? They go from the top to the bottom or the bottom to the top. The product rule, you got to add those exponents up, all right? The quotient rule, you got to subtract your exponents. And then the power rule, you got to multiply your exponents. So, guys, there are 3 different rules. Make sure you pay very close attention to what it's asking you to do. All right, guys, thank y'all so much.